Hey guys, we're working on a Unit 2.4 review, so I need that darkish yellow sheet in front of you, and I'd also like you to take out the green graphic organizer so you can have that right next to you. I'm going to refer to that as much as I can. Okay, so let's work through questions 1 through 3. So, questions 1 through 3, we have to simplify radicals. First thing you have to remember is that you can only multiply numbers that are outside the radical together, so 2 times 3, so that gives me 6, and numbers underneath the radical together, so 5 times 20, still under the radical, is 100. And now I can simplify separately. 6 stays as 6. Square root of 100 is 10. So 6 times 10 gives me 60. Final answer. Okay, question 2. Square root of 300. I need to figure out if there are any perfect squares that are factors of 300. Well, 100 is a factor of 300. 100 times 3. Well, square root of 100 is 10. It's not a square root anymore because I took the square root times the square root of 3, which we can't simplify anymore. Question number 3. Remember, if I have a square root in the numerator and denominator, I can simplify them separately. Well, the numerator, the square root of 16 is 4, and 150 we can split up. So I'm going to do a little side work right here. Square root of 150. Any perfect squares that are factors, 4, we probably can go bigger than that. So let's go 25. So square root of 25 times 6. Well, the square root of 25 is 5. The square root of 6 we can't simplify. So I have 5 root 6. Remember, I don't like to leave radicals in the denominator, so I need to multiply by a form of 1. In this case, if I have a square root of 6, then I need to multiply by square root of 6 over square root of 6. And now let's multiply across. In my numerator, I have 4 times the square root of 6. In my denominator, 5 times 1, because its leading coefficient is 1. And square root of 6 times square root of 6. Remember that the square root of 6 times square root of 6 gives me the square root of 36, which is 6. Okay? And now I can simplify. 4 root 6 stays in the numerator. 5 times 6 is 30. So I have 4 root 6 over 30. And now we can simplify 4 over 30. Well, if I could divide by 2 in both of those, so divide by 2 gives me 4 divided by 2 is 2. 30 divided by 2 is 15. So my final answer is 2 root 6 over 15. Okay, so now you need your green sheet. Here we go. Look at the column that says right triangle with altitude, because that's what this is right here. Let me point it out. This is our altitude. Okay, and altitude is from the right angle, drop to the opposite side, creating a 90-degree angle. So now I can use that. I'm going to compare, let me highlight a few things. I'm going to compare this small triangle, because I have x and 3, and I'm going to compare this medium triangle, because I have x and 9. Okay, so those are the two triangles I'm going to use. We'll start with the small triangle. X over 3 equals 9 over x. Now, if you don't remember how to set it up, you can always think the smallest side of the small triangle over the medium side, and then the small side of the medium triangle over the medium side. Or you can remember that you have to have a number, a geometric mean that repeats diagonal of itself. So now we can cross multiply. So I get x squared equals 27. Square root both sides. Oh, I need to simplify the square root of 27, so let's do some work on the side. Well, square root of 9, and 9 is a perfect square, so that's why I picked it. So I get 3 root 3, so x equals 3 root 3. Okay, next question. This one has two side lengths of a right triangle, and I need to find the third. Well, here we go. Look at your columns. What gives you two sides, and you have to find the third side. Pythagorean theorem. So a squared plus b squared equals c squared. Well, I know that this has to be my hypotenuse. That's what I'm looking for because it's across from the right angle. So these are my two legs. 2 squared plus 4 squared equals c squared. Let's simplify. 2 squared is 4. 4 squared is 16. Let's combine like terms. I get 20 equals c squared. Square root both sides. There you go again. If you look in the column, it says you have to complete an exact radical form. So the square root of 20, let's simplify that. Perfect square is a factor of 20, gives me, let's go 4, because 4 is a perfect square, and that gives me 2 root 5. So c equals 2 root 5. Okay, question 6. Well, if I look at this problem, you'll see that I'm given a 45-degree angle right here. Okay, that means I need to use my special right triangle, 45, 45, 90. So let's try this out. So what I'm going to do is I'm going to write the actual pattern of a 45, 45, 90. Across from the 45 is always A, and across from the other 45 is always A, and then across from the 90 is A root 2. Well, if you look, the only side that I'm given is across from the 90, so this is the equation I can set up. 12 equals a root 2, because once I find a, I know my other two side lengths. So if I'm trying to solve for a, I need to divide by square root of 2, divide by square root of 2. So those cancel out. So I get 12 over root 2. So I'm going to write that, because remember we have to rationalize denominator. Multiply by a form of 1, which is square root of 2 over square root of 2. Multiply across, I get 12 times the square root of 2 over, well, square root of 2 times square root of 2 is the square root of 4. Simplify that, I get 2. And now we can simplify 12 over 2, which is 6 root 2. So both of my legs are 6 root 2. Okay, let's take a look at the bottom left, number 7. Well, I'm given a right triangle with two sides, trying to find the third one. Pythagorean theorem again. Okay, and if you can't find that, look at your green sheet, find the column that says given two sides, and the column that says find one side. So a squared plus b squared equals c squared. But now in this case, I'm given the hypotenuse because it's across from the 90-degree angle. So that's my c. My b, it doesn't matter if it's a or b, but 15, and then let's find the missing side. So a squared equals a squared plus 625. Sorry, that's 25 squared. So 15 squared. We cross that out. We get a squared plus 225. And 21 squared is 441. Subtract 225 from both sides. Well, if I take away 200, that's 241 minus 20 is 221 minus 5 more is 216. So now I need to square root both sides. Well, square root of 216 is not a perfect square, so I need to actually simplify it. So if I have 216, well, find the biggest perfect square with the factor of 216. 36 is times 6. Well, square root of 36 is 6. And the square root of 6 cannot simplify, so we get 6 root 6. Okay, two more problems on this page. If you look at question 8, I'm given a 30, 60, 90. So find the column with the 30, 60, 90, and then we're going to write the pattern. Across from the 30 is always a. Across from the 60 is always a root 3. And across from the 90 is always 2 times a. Well, this is the only side that I'm given an actual measurement, so that's the equation I can set up. 2a equals 15, and I need to solve for a, because then I have this side across from the 30. So divide by 2, divide by 2. A equals 7.5, or 15 over 2. So that means that this side length over here is 15 over 2, or x is 15 over 2. And then I take this a value, and that's literally the a value that I'm going to plug in for this a. It's the exact same number. So if across from the 60 is a times the square root of 3, and a is 15 over 2, then across from the 60 is 15 over 2 times the square root of 3. Last one, this is the new material, the trig. Okay, if you look in all three parts, sine of d, cosine of d, tangent of d. So I'm looking from this angle right here. So I'm going to label opposite, adjacent, and hypotenuse. Okay, opposite is across, adjacent's next to, and hypotenuse is always across from the 90. And remember, sine is opposite over hypotenuse. So that's going to be d, because that's the side opposite that angle, over e. Cosine is adjacent over hypotenuse. Well, the adjacent side is r, and the hypotenuse is e. And tangent is opposite over adjacent. Well, the opposite side is d, and the adjacent side is r. Okay, on this second page, you're going to need a calculator in front of you, or you're going to need to at least open up a browser so that you can check some calculations here. Sine of a 38-degree angle. Well, we're given the angle, we're trying to find a ratio of sides, so that means I need to use the original sine. So I'm going to click sine of 38, close my parentheses, hit enter, and we're going to go to, let's say the 100th, so let's say 0.615, so I got to round that up, so 0.62. Okay, tangent of 68, so I'm going to hit the tangent button of 68-degree angle, and that's going to give me 2.475, which we got to round up, so 2.48. Okay, question 12 and question 13, we're looking for an angle. Remember, when we look for an angle, we have to use inverse trig functions. So if it's tangent of A, I need to use inverse tangent, or under calculator is second tan, of this number, 1.4320. So inverse tan, 1.4320, hit enter. It's going to be approximately 55.07, so that angle is 55 degrees, 0.07. Let's try the next one, inverse sine of 0.5. Inverse sine of 0.5, because I'm trying to find an angle measure. So second sine of 0.5, it's going to be a 30-degree angle. Okay. For all these pictures, 14, 15, and 16, I'm going to draw a picture. Okay, the perimeter of a square is 24 centimeters. So here's my square. I know it's got some right angles. Got my right angles here. And I also know that if the perimeter is 24 and all the sides are congruent because it's a square, that means I can take 24 divided by 4 to give me the side lengths, which is 6 centimeters all around. So 6 centimeters, 6 centimeters, 6 centimeters. Now I'm looking for the diagonal of the square, so let's draw the diagonal. If I take this triangle and I take this square and I know that all angles are 90 and I cut it in half by a diagonal, that means I'm going to get a 45, 45, 90. And remember that the legs in a 45, 90, 45, 90 are A, and then the diagonal is A root 2. Well, if A equals 6, that's what I'm given right here, that means the diagonal must be 6 root 2 centimeters long. Okay, question 15. A tree casts a shadow of 86 feet. Okay, that's going to be awkward. Here comes a tree. Boom. Tree. Casts a shadow of 86 feet. There's its shadow. Find the height of the tree if the measure of the angle the sun's ray makes to the ground is 32 degrees. Okay, so here comes the sun. I wish I had more colors. I got red. That's all I got. Here's my sun. It casts a shadow all the way out here that is 32 degrees. Okay, and I'm trying to find the height of the tree, so let's label this X. Okay, this is trig, 32 degrees. It's not a 30, 60, 90. It's not 45, 45, 90. So here's my right triangle. Hopefully the tree is perpendicular to the ground. Here we go. Here's the angle I'm looking for, so let's label opposite, which is O, adjacent, which is A, and the hypotenuse, which is H, crossing the 90-degree angle. And now let's set it up. Which trig function deals with opposite, which is the X, that's this side over here, and the adjacent? Well, if you look at your trig functions, you'll see that tangent deals with opposite and adjacent. So let's set this up. Tangent always of the angle, so of 32, equals opposite, which is X, over the adjacent, which is 86. And now we can solve. So on your calculator, I know that I'm solving for a side length, so I'm going to be using original trig functions, no second trig, the original trig. So let's click tangent of 32, get our decimal here, 0.625, 0.625 equals X over 86. If I want to get X by itself, I need to multiply both sides by 86, because right now it's X divided by 86, and to undo division we have to multiply. So I'm going to take this number 0.625 and multiply by 86. That's going to give me 53.75. We're in feet, and that's X. That means the height of the tree is 53.75. Last question, question 16. Let's read it. A 32-foot tree casts a 70-foot shadow, while a nearby building casts a shadow of 114 feet. How tall is the building? If you want to draw a picture, absolutely go for it. Here's my tree. It is 32 feet. It casts a shadow that is 70 feet. Okay. We also have a building. Here's my building. Oh, window. Nice window. Maybe a little door down here. Window. Cool. It casts a shadow of 114 feet. Well, they should be similar triangles, and we're trying to find how tall the building is, so let's label this X. So any proportion will work. If you want to stay with the tree for the first ratio and then the building for the second, go for it. If you want to go height and shadow, whatever you want to do. Here's what I'm going to do. I'm going to go height over shadow, so the height of the tree is 32, the shadow of the tree is 70, equals height, which of the building is X, over the shadow, which is 114. And now we have a ratio. Height over shadow equals height over shadow. Remember, H over S equals H over S. Now we can cross multiply and solve for X. 70X equals 32 times 114, which is 3,648. I need to solve for X, so let's divide by 70. Divide by 70. On my calculator, divide by 70. I get approximately 52.11 feet. The height of the building is about 52.11. That's an 8, sorry. 52.11 feet. There's my height, 52.11 feet. Okay, guys, there's all the problems. Let's get ready for this quiz.